In this video, we're going to talk about the substitution method for solving a system of linear equations. The substitution method is going to be a great method to use if it's easy to isolate one of the variables in one of the equations. So the substitution method, this is the best method if it's easy to isolate one variable in one of the equations. And what we do is, so we isolate that variable, and then we take that, so we have like y equals blah, 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 x, blah, blah, blah. We're going to take that equation and substitute what y is equal to in that equation into the other equation. That gets one variable in that second equation, and then you can just solve for that variable. That tells you one of the coordinates of our system's solution. So then to figure out the other one, you would take that solution and plug it back into one of the original equations. When we're solving a system of linear equations, it's important to keep in mind that the solution is a point, and a point has two coordinates. So you need to find both coordinates of the solution to that system. Okay, so in our first example, in either equation, do we see that it's easy to isolate one of the two variables? Sure, x is already isolated in the bottom equation. So what we're going to do is we're going to take what x is equal to and substitute it in to the top equation. So I'm going to replace x with y minus 1. This would be 4 times y minus 1 minus 3y is equal to negative 12. And now I'm going to get y by itself. So 4y minus 4 minus 3y equals negative 12. I'm going to combine my like terms, and I'm also going to add 4 to both sides. So add 4 to both sides, and we get 1y equals negative 8. So this is the y coordinate of the solution. We need to also determine the x coordinate. We're going to go back to our original two equations. Which one looks like it's going to be easier to work with when we plug in negative 8 for y? Probably the bottom one. This one has a lot more going on. So we're going to take negative 8 and we're going to replace it for y in the second equation to give us the x coordinate of the solution. So x equals negative 8 minus 1, and x would be negative 9. So the solution to this system would be negative 9, negative 8. It's always good just to do a very quick check. It is very easy to make a mistake when we're solving systems of equations. So we just want to verify in this equation, since I didn't use this one in the second part of the solving, I just want to make sure, very informally, that this really does work. So I'm going to plug in negative 9 for x. So 4 times negative 9, and 3 times negative 3 times negative 8. So this would be negative 36 and positive 24. If I add those together, does that give me negative 12? Yes, it does. So I feel pretty confident that negative 9, negative 8 is the solution to the equations. In our second example, we have y equals 2x minus 5 and y equals 3x plus 6. For this one, substitution method is an ideal candidate because we actually have both equations are solved for one variable. They're both solved for y. So this is actually called the transitive property. If we know y equals this and we know y equals this, then we know that this equals this. So we're going to say 2x minus 5 is equal to 3x plus 6, and then we're going to get x by itself. So I'm going to take away 3x from both sides, and I'm also going to add 5 to both sides. Now I took away 3x from both sides because I want to get the variable on the left-hand side. In retrospect, I realized I probably should have subtracted 2x from both sides to keep the variable positive, but I've already made my decision. So we have negative x is equal to 11. To get x by itself, I would need to divide by negative 1. So I'm going to divide both sides by negative 1, and I get x equals negative 11. Now we know the x coordinate of the solution. We need to plug it into one of the two equations. They're both pretty reasonable. I'm going to plug it into the top one. And so we're going to say that y equals 2 times negative 11 minus 5. That's negative 22 minus 5. That's negative 27. So I believe the solution to this systems of equations is negative 11, negative 27. But we want to just do a quick check. Let's just make sure that those also work for our second equation to make sure we didn't make a silly mistake somewhere. That would be negative 27. Does that really equal 3 times negative 11 plus 6? That's negative 33 plus 6. Yes, that adds up to negative 27. So I feel pretty confident that negative 11, negative 27 is the solution.